Welcome back, class. Today we've been, this unit we've been talking a lot about parallel lines and the angles. Today we're going to introduce perpendicular lines and talk a little bit about some of their relationships and how they also relate to parallel lines. So by definition first, a perpendicular line is a line, perpendicular lines are lines that intersect to form 90-degree angles. Okay, so for example, if I wanted to draw a picture of this, if I drew this first line, and I'm going to call that line L, and then I drew this line to intersect, we're going to call that line M, and if I show that there is that 90-degree angle, then I could say that line L is perpendicular to line M. Now I do want you to notice the symbol for perpendicular. It kind of looks like a little upside down T. That's meant to help us notice that little like perpendicular right there. You don't need the little square in the corner, but that's what that symbol means. Okay, now the perpendicular postulate pretty much says that if we're given a line and a point not on the line, then there is exactly one line that goes through the point and is perpendicular to the given line. So what that means is, if we draw a little diagram of this, okay, it says that we're given a line and a point that's not on the line. So very simple. I'm just going to draw a line, and then I'm going to draw anywhere I want. I'm going to draw a point that's not on that line. According to this postulate, there can be only one line that goes through that point and is perpendicular to the line that I originally draw. So if I can draw one line coming right down here through that point and perpendicular to the line that was given. Now, the parallel postulate, very similar. It says if given a line and a point not on the line, then there is exactly one line that goes through that point and is parallel to the given line. Okay, for example, once again, I'm going to draw a line and a point that's not on the line. So if I draw a line like this, and again, I can draw a point anywhere, what this one says is that there can only be one line that goes through that point and is parallel to the other. Now remember, we show parallel lines with using little arrows, so I'm going to put little arrows on these to show that these two lines are now parallel. Okay, so a little bit adding on to that. We're going to draw a little example here. It says draw AB. Now keep in mind the notation. This is telling me to draw a segment. So I'm going to just draw a segment. I'm going to draw a segment with endpoints A and B. And then it says we're going to draw a line, again, notice the notation, that is the perpendicular bisector of AB. So perpendicular means that when these intersect, it has to form a right angle. Bisect means that it has to cut in half. Okay, so we're basically going to draw a line that cuts AB in half. And it says at point M. So that means the halfway spot is M. So if I go back to AB, mark the halfway point, and I'm going to call that M. And then I'm going to draw this line going through it. This line is XY, so I'm going to add XY to that line. I want to show that this line is perpendicular, so I do need to put in my little right angle to show that it is perpendicular. And I need to show that it's a bisector, which means I'm going to mark the two sides of AB as being congruent. Okay, so what are the three conclusions we can draw from this picture? Well, we kind of just stated them. Okay, number one, we can conclude that segment AB is equal to, take that back, segment AM is equal to segment MB. Because they were bisected, we can conclude that M is the midpoint of segment AB, because if M is the point in the middle where they were bisected, then it's the midpoint, and we can conclude that the measure of angle XMB, and honestly, we could name any of those angles. I just named this one right here. Okay, we conclude that that angle is 90 degrees because it was perpendicular. Okay, so just by calling something a perpendicular bisector, we're actually given a lot of information. Okay, so let's define that information. What is a perpendicular bisector? A perpendicular bisector is a line or part of a line, could be a segment, could be a ray, that intersects a segment at its midpoint to form right angles. Okay, so by drawing a perpendicular bisector, we're just basically bisecting a segment, we're identifying a midpoint, and we're getting right angles. Okay, so in our first example here, it tells us that this segment RS is the perpendicular bisector of JL. Now, the reading of this is really important, especially that word of, because the question says, can you conclude that point K is the midpoint of RS? Do we know that K is the midpoint of RS? Well, based on this sentence, RS is actually doing the bisecting. What's being bisected is segment JL. So JL is actually what was cut in half, which means that point K is the midpoint. Point K is the midpoint of JL, meaning that JK and KL are congruent. However, we cannot conclude that K is the midpoint of RS. It doesn't say that RS was bisected. It said RS did the bisecting. So I could have easily drawn the picture like this. I could have drawn segment JL, marked the midpoint as K, and then I could have drawn segment RS like this, where we can clearly see that K is still the midpoint of JL. JL was still bisected. However, RS was definitely not bisected. So be careful on the wording of things. If I tell you that the perpendicular bisector of CD intersects CD at point P. Okay, so again, even though these questions are non-algebraic, the picture is going to help you to visualize this. So we've got a perpendicular bisector of CD. So what that means is that CD, that segment, was bisected at point P. Now that perpendicular bisector could be anything. It could be a segment, it could be a line, it could be a ray. Okay, I'm just going to draw that perpendicular bisector. Okay, CP is 12. They tell us that this part is 12. Because CD was bisected, that means that this is also 12. So when it asks for what is the length of CD, that's going to be 24, the full distance. Okay, a couple more quick examples where we're going to really try to be able to prove some stuff. Given that, and again, notice the symbol, given that L is perpendicular to N. So here's L and here's N. If they're perpendicular right away, I'm going to mark a little right angle here to show that. It also tells us that point M is perpendicular to N. Oh, I'm sorry, line M. Here, so here's line M. Is also perpendicular to N. So I'm going to draw another little right angle. And we want to prove that L and M, that's these two lines, we want to prove that they are parallel to each other. Okay, when we're given a proof, we're going to try to write out a couple of sentences that can really explain how we know this. Okay, and you can start with a lot of different things. I'm going to start with the fact that angle 2 is going to be congruent to angle 4 because they are both right angles since the lines were perpendicular. Since the lines were perpendicular. So it's important to be very specific when we're explaining things, okay? Angle 2 and angle 4 are congruent because they're both right angles because it said they were perpendicular. Okay, now I can also say that angle 2 and angle 4 are corresponding angles. And that was based on our definitions from before. Corresponding angles means that they're in the same position, but on these two different lines, okay? We also know that if corresponding angles are congruent, then the lines are parallel. So because angle 2 and 4 were congruent And because angles 2 and 4 are corresponding, we can prove that the lines are parallel. Okay, so it's just kind of giving some reasons for why. Looking at example 4, what information do we need to know to be able to prove that line M is the perpendicular bisector of AC? So we want to be able to prove, remember, of AC. That means we want to prove that AC was actually bisected. Okay, well, in order to prove that, one, we're going to have to know that it was bisected. So we're going to have to know, does AB equal BC, right? In order to prove that it's bisected, we need to know that those two pieces are equal. We also need to prove that, keep in mind the word perpendicular, we need to prove that they intersect to form right angles. Okay? So without knowing that, we can't look at a picture and just assume that things are perpendicular bisectors. Okay, however, if we go to the next example, given that line M is the perpendicular bisector, okay, so now that we know that line M is the perpendicular bisector of AC, we know that these two pieces are equal, and we know that there's a right angle here. Now, with that in mind, can we answer this question? It says that segment AB, so that's here to here, is 4x minus 1. We know that BC, from here to here, is 2x plus 7. Can we solve for x? Well, yes, because we know that bisect means that they are equal. Therefore, the 4x minus 1 will have to equal the 2x plus 7. And we can solve this equation, get the like terms on the same side, move the constants to the other side, and divide to solve for x. So we could actually solve that one because we knew already that it was a perpendicular bisector. So you guys are going to be working on some stations and some practice today, and some of these kinds of questions will come up as you're working on some of those.